Hi, this is Mr. Bouchard from Port Jefferson, and I'm here to talk to you about the introduction to earth science. Alright, and the first thing we're going to talk about today is the scientific method, which pretty much begins any science course, pretty much. So these are just some of the basic concepts and basic things that we'll be using throughout the year. First thing I want to talk about with you guys is observations. And observations are basically a perception of something using your human senses, right? And we do this all the time. Whenever we're looking at objects, we are using observations, right? So it's basically using your human senses to describe an object, right? And the types of words that you know you're using in observation are adjectives, describing words, right? So again, the five senses: sight, hearing, touch, taste, and smell. So if you're using any of those things to just describe an object, then you're making an observation. All right, so some examples. The rock is shiny. The folder is green. The weather is cloudy. This room is smelly. This floor feels slippery. All right, so in other words, these are factual pieces of information. And they're just using your senses to describe the object, and that's it. Okay, sometimes we're not able to do this very well, so we need the aid or help of instruments. So in the case of instruments, they're basically a human device that helps to make better observations. All right, so sometimes we want to look at objects that are super small. So to make our sight better, we use a microscope or a hand lens. If we want to know how large something is, rather than just saying it's big, we measure it. So you use a roller, a meter stick, measuring tape, whatever object to measure it. Instead of just saying it's hot in here, we could actually use a thermometer and figure out it's 78 degrees in here right now. So basically you're using instruments to get exact data, and that exact data still is an observation, it's still factual information gathered with your senses, all right? But it's using an object to make a better observation. That's what an instrument does. Okay, after observations are made, we then make inferences in our mind. Inferences are conclusions, opinions, or explanations of observations. They can be identifying objects, all right, in the case of like rock identification, or types of clouds. Also, it can be predictions, right, which I'll get to in a moment. So examples of types of inferences. Tomorrow it's going to rain. It will be warmer tomorrow. Weather definitely comes to mind big time with this. I think Johnny made this mess. All right, it might not have been Johnny, but you're making a guess because maybe he sat in that seat. So it could be his mess on the desk, but you're not sure until you ask Johnny. All right, and that's what an inference does differently. Observation, you see it happening. All right, you see Johnny making that mess. An inference, you're making a guess, an educated guess. That's the way I like to think of it. The rock is obsidian. All right, maybe I'm wrong. Maybe it's really basalt. All right, so in other words, there is some uncertainty to an inference. All right, predictions are a type of inference that attempts to tell the future. So weather forecasting obviously is a prime example of that. All right, also in science, that's very important, is classification. All right, and pretty much any object that is named is being classified. So it's grouping of objects with similar characteristics. All right, so when I look at these vehicles that are here, I can make many different categories. I could break them down into, you can probably even think of it in your mind, red cars versus black cars. So we can go by color. We could also go by type. We could go sports cars versus sports utility vehicles. You could go off-road versus on-road cars. Okay, so we can go on and on and on. You can go by size of tire, any sort of descriptions. You can go car versus truck. All right, so classification is a way of organizing it so it makes better sense. And we do that all the time in science. You're going to see a lot of classification of things throughout the year. You probably recognize this from previous classes, and when you take a living environment in the future or bio. The 5 kingdom model, so Monera, Protista, fungi, plant, animal, all right, which are groupings to make objects more meaningful to you. Clouds types, we won't have to memorize these in our class, all right, but these are the types of clouds: cirrocumulus, cirrus, altocumulus, altostratus, cumulonimbus, stratocumulus, stratus, cumulus. All right, these tell you about what type of weather is going to be coming. All right, and obviously the cumulonimbus are the storm clouds. You can tell that right from this. All right, but if you want to go and learn more about that, you can. All right, what each of these clouds, what type of weather conditions they bring. Okay, other definitions. Measurements obviously are done with instruments. They're basically making an observation with greater accuracy or precision. So obviously we have length, mass, volume are our 3 major measurements that will be done in this class. So length, we can do meters, centimeters, millimeters. You can do miles, feet. We usually use the metric for the most part, except for in mapping maybe, meteorology. Mass could be in grams, kilograms. Volume will be in milliliters or centimeters cubed, as an example. Okay, units of measurement will always be used with these numbers, all right, these measurements. Okay, volume of cubes or rectangles. So here's an example where you'll be using a formula to calculate the volume, and you've probably done this in math class. Volume equals length times width times height. You should have that memorized. Okay, so in this case, 5 times 5 times 5, again, will give you 5 times 5 is 25, times 5 is 125. So the answer to this is actually, I'll write it up here. Five times 5, which is 125 centimeters, and it's going to be cubed, all right, because cubic centimeters, because this is a 3-dimensional object. Areas, on the other hand, tend to be centimeters squared, all right, which are 2-dimensional. So this is a 3-dimensional, that's why it's centimeters cubed. Okay, volume of irregular shaped objects. Sometimes spheres actually have a easy calculation that you could do. In the case of a rock, not so much. So what we do is we use something called the volume displacement method. All right, so you take an empty cylinder, you fill it to a certain level, whatever happens to be measurable, and this happens to be 7 milliliters. And then I drop my object in, you see how much it raised by. So it went from 7 to 9, so 9 minus 7 gives you that the object's volume is 2 milliliters. Okay, so it's a simple little math thing. And obviously, if we do this in lab, you guys would actually measure that. And the one thing that's not shown here is something called the meniscus. When you put stuff in a graduated cylinder, the water will actually curve, and you always read from the bottom of the meniscus. So read bottom of meniscus. Okay, so that's what that curvature of the water, because the water tends to cling to the bottom of the or the sides of the container. Okay, and that's why it ends up looping downward. Okay, so you get that bottom curvature. So always read the bottom of the meniscus. Okay, and lastly, this is percent deviation. All right, this formula tells you how far you are off in a basically experiment. So the things you need, obviously, are the accepted value. And you ask, what's the accepted value? It's like doing the experiment over and over many times and taking the average. Okay, so it's basically the correct answer, if you will. All right, so percent deviation is equal to difference from accepted. So you're going to subtract your experimental and your accepted values and take the absolute value of them. All right, you're going to keep the number positive. And then divide by the accepted value. again, and then multiply times 100%. And the reason why times 100%, because you're going to end up with a percent as your final unit. So here's another example, which I'll do up on the smartboard. So just give me a second. A student measures the mass of an object to be 127.5 grams. The accepted or actual value is 125.0 grams. What is the percent deviation? Okay, so all you're simply going to do on top of the fraction, you're going to go 127.5 minus 125 divided by 125, because the accepted goes on the bottom, and then multiply times 100%. All right, if I do that math real quick, always type the top in first. 127.5 minus 125 equals 2.5, divided by 125 times 100%. My final answer is 2.0%. The reason why I wrote 2.0%, it is a significant digit, right? So you'll learn about that in the future when you take chemistry and physics. You see 0.0 and 0.5, so we're accurate out to that digit. So in this case, we're going to round to the nearest tenth, and that's why you have to show that 0.0 exactly. All right, so that's pretty much it for this PowerPoint, and I will catch you next time.